We are back, is it right? Now listen here, I just want to tell you some more important things. So the next topic, it will be around linear or non-linear, okay? So I just want to tell you about the linearity as well as the non-linearity here. Linearity represents, so if a system is going in a very good fashion, that means the input is coming and output is getting the desired, to get the desired output means what? That's our linear system. And if input is something and if the output is something different, appropriate asset of the desired thing, and that's called what? It's a non-linear function, okay? So here in the linear, what represent means the time of the total classification of two systems, it should be equal to the time of the individual. So we can have the A1, A2, and these are said to be the arbitrary constants. Okay, so constant means you can have anything. Example, you can have your terms. For example, in terms of electrical, suppose if we are having a transformer supply, for example, this is a transformer, okay, and you are giving to two houses means, so the total power is given by the transformer is equal to the power from the transformer to one house and the power from the transformer to another house. In this way also we can represent in the form of an electrical way, okay? So, but it should be equal, okay? So now we should go about the linear function. So linear function, how I represent means you just take this one and you represent the form of the diagram. So x1 is multiplied by a1 and x2 is multiplied by a2. So a2 means what? So for example, x1 means it's the house number 1, x2 means the house number 2. A1 represents number of constants, that means what? Number of plug points in a house, that also you can represent. And A2 means what is number of plug points of house number 2. So likewise you can have the constant. Constant is, doesn't matter about this. So it can be multiplied with the houses, household appliances. So we just got to multiply this one. And finally, after multiplication of this one, you get x1 of n into a1, x2 of n into i2, and totally plus, you may go for this whole system. These are getting added, is it right? And after adding, it should go through a system. That means what's the time, and afterwards it is giving the output. So now what I do, I represent this one here once again, is it right? So look at here, a1 T represents the system. System means what? For example, if a transformer is giving supply to a house, means a transformer system which is having the input as well as output, input from a AB station, and is giving output to more houses, is it right? In the same way, so you are giving, so here what will be having means here I have to use x1 of n, here I have to use, and here I have to use the x2 of n. x2 is going in a system and it should multiply by a1. Look at here, x1 of n is going in a system and multiplied by a1, and plus x2 of n is going to a system and multiplied by a2. So this whole will represent the form of this diagram. It's very simple, okay? And now what we do, just got this output. So now what I do, we just want to know about how the examples would be more relevant in this case, okay? So now we shall see example. So now what I do means that just please copy this one, whether if you want to copy or if you have a small note, I just give a small time for about 30 seconds. So until that, I just wait for you and just make copy. Okay, I hope everyone has copied everything. Okay, now we just go to some small problems. Okay, straight back. I just rub up this one. Please, mine. Please wait. So let us take a small example. First example means I have the example of y of n is equal to x of n squared. So whatever for the in terms of a linear as well as non-linear system, suppose if an output is giving input means okay, so from the input, from the input as you are getting output means what we have to do, we have to split the input into two forms. Okay, for example, if I got y of n equals to x of n, you have to divide the x of n into x1 of n as well as x2 of n, and that you should have to do. whatever input you are getting from the so for the feedback from the output, and you should have to divide the input into two terms. So we just look about whether it's linear or non-linear, and then for checking purpose we just do make a small splitation. Now look at this one. Now we got y of n is equal to x of n square, right? As of my trade, I just making a small split. How do I split? Means I just take y1 of n is equal to x1 of n square, and y2 of n is equal to x2 of n square. I got the two classifications. Okay, now we see about this one. Now what I do, I just apply everything. So what I do, t of a1 x1 of n plus a2 x2 of n, which is equal to t of, sorry, this is once again, I just have the constant here. Okay, a1 into t of x1 of n, we got it as a right, and then plus i2 into t of x2 of n. This is a default formula. Okay, so this is a default formula. I hope everyone got it now. Now what we have, I got the term of x1 of n as x1 of n square, x2 of n as x2 of n square. Look at here, we don't confuse square is here, square is not, cannot like that. Okay, so this is the term of input x of n. This is the term of output y of n, which is modified in different way. That is the simple problem. Okay, we don't want to worry about this one. Now what I do, I'm applying here. So first I take a whole, this one as a y3 of n. Okay, and now I will take the whole thing as a y3 dash of n. So how to check the linearity representation means, so if the y3 of n is equal to y3 dash of n, that means what, the system is linear. Unless if the y3 of n is not equal to y3 dash of n, that means for the system is had to be non-linear. Okay, so we just check about the linear and non-linear right now. So now I get the y3 of n is it right. Now we get to this one. So I hope everybody just can see the board clearly. Now look at here, we take a y3 of n. So y3 of n is equal to t of a1 into x1 of n square plus a2. Look at here, this whole is about x, is it right? Time of this x. So what I do, I'm going to have the separate form. So look at here, and a2 of x1 of n square. As of the question here, so look at here, the n will be replacing by square term. Okay, so none other you should have to replace. X will be just replacing, that's the only thing. So we don't want to just scaring or anything. That is the only thing. Okay, now we go to, say this is about the y3 of n, we got to apply it here, is it right? Now what we do, so we are going to take this one. So now we just multiply here. This is equal to t of a1 x1 of n square, so plus t of a2 x2, so this is one is x2, right? I'm sorry, x2 of n square. Okay, so which will be equal to, I take the constant outside, a1 into t of x1 of n square, and afterwards plus i2 into t of x2 of n square. So I got the two classifications right, and now this is the final answer of y3 of n. This I got it for y3 of n. Now we got to check about y3 dash of n. Okay, look about here. So y3 dash of n represents here. y3 dash of n, which is equal to the same thing I'm applying, a1 into t of, instead of x1 of n, I have to replace this n by n square. So x1 of n square, and I close this one, and plus a2 into t of x2 of n square. So from the equation, look at this one, 1 as well as 2, we found out that y3 of n is equal to y3 dash of n. Okay, so now listen here, y3 of n, which is equal to y3 dash of n. So if both system, so both as equal means what? The system is linear. Okay, the system is said to be linear. Now in the next video we just see about what about the non-linear. If I just give a small example. Okay, thank you very much.